Now, so far we've looked at examples of changing an object's angular momentum when there is a net external torque being applied to the object. But I want to take a moment to revisit the law of conservation of momentum when we talked about systems in which there was no net external torque. And so as a reminder, in linear or translational motion, we said that in the absence of a net external force, the linear momentum of a system was conserved. And so, as an equation, right, we said that the total momentum of the system before the collision had to equal the total linear momentum of the system after the collision. Now, we can do the same thing for rotational motion. In the absence of a net external torque, then, not a force, but a torque, the angular momentum of a system is also conserved. And you can actually test this at home. If you have a straw, a piece of string, and a metal washer or something weighted to hang on the end of the string, and you begin to spin the washer around the straw, if you pull on the string in the middle of the straw and reduce the radius that the washer is traveling in, you're not applying a torque because you're applying a force at the origin or the center of rotation, so your lever arm will be zero, right? You're not going to be applying a torque. You'll see that the angular momentum of the washer will stay the same. And the way that will work is by coming smaller in a smaller circle, right? The moment of inertia of that washer system will decrease. And you'll see the washer begin to spin faster to account for that decrease in its moment of inertia. And so you can test this concept at home as well. But this is how we can apply our conservation of momentum equation from linear momentum to angular momentum. And in equation form, it would look like that.